Hi, I'm Gretchen, and this is my Physics 2211 Lab 2 on motion of a falling object. The purpose of this is to compare gravitational force to gravitational force and drag on the same computational model, also compared to just the force of seen in actual experimental. And we did this by dropping an object that was somewhat lightweight, less than like a rock, and comparing that to the model of both the one that included drag and just the gravitational force by itself. My main results were that the force with the drag computational model was much closer to the actual experiment, and the just gravitational was way off of the one with the force of drag. So for this, the physics concepts are basically the Newton's second law, which is force equals mass times acceleration. And in this case, we are doing a force of gravity, so that would be mass times the gravitational force. And so I based my code off of all these different equations, mainly the final velocity equation, the update one, to find the different final velocities with the force changing. So this is my tracker video. For this, the mass of the ball was 5 grams about, so obviously 0.00 kilograms. No initial velocity, and then the force of gravity on the ball just by itself is 0.049 newtons. The ball is obviously going in the negative y direction, and the system is the ball and the surroundings are the air. So looking at my code for the computational side of this, I use the velocity update formula for my main formula in this, along with the force formula to find the force of the ball with the gravitational force of the ball. Other than that, the only thing changed was the ball's mass, and for this one, because it's just the gravity one, the b equals 0. As seen here, the ball's velocity changing with this equation, and the position changing with just the new updated velocity each time. For the one with gravity and drag, I found through trial and error a b of 0.0048, and to add that all together for the velocity update formula, I added the fnet that we already had and the force of the drag using the drag force formula given through like the lab instructions, and then making the f total of the fnet and the force of the drag. So for the results, the ones that are almost, you can barely tell that they are even separated, that is the experimental, and then the gravity and drag. The experimental one is pretty far from the gravity only one, with that being just because the gravity only is not taking into consideration the drag force that is going against the gravitational force. So using the trial and error b value, the coefficient of drag that I found, the gravity and drag was actually very much extremely online with my experimental gravity and drag force, obviously. Going into the discussion questions, the main one is, do any of the models predict terminal velocity? So looking at these 3 graphs, which this one here is just the gravitational force alone, this one is the drag force and gravitational with no initial velocity, and this final one is with an initial velocity being one of the discussion questions. So with all 3 of these models, this one with the gravitational force alone is just does not take into account, does not have terminal velocity, because it will continue on accelerating forever and forever because there's nothing stopping it. But then these 2, because they have drag force going in the other way, it will eventually even it out to where it will reach a constant velocity. So for both of these, the same change in velocity happens, but for the with the one with the initial velocity, you're just really reaching that velocity faster, and going to a larger one, and reaching that velocity faster. Yeah. So yeah, that's all for my presentation. Thanks.